In this video, we'll study how to find composite function from piecewise defined functions. Now, basically, there are two methods. One of them is graphical method, and the second one is algebraic method. So, we'll study these two methods with three graded examples. Now, this first example is we are given this function fx, which is defined as minus 1 plus mod of x minus 1 when x lies between minus 1 and 3. Now clearly fx, it is a continuous function and we have this mod x minus 1. Now root of x minus 1 is 1, rightmost plus, this is minus. So when x is less than 1, it takes a negative value, and when x is greater than 1, it takes a positive value. So we can write this function fx as, now for this first interval, when x lies between minus 1 and 1, we have this minus sign here, so it will be minus 1 and then minus x minus 1, and then we have the second interval where x lies between 1 and 3, so it will be this minus 1 plus x minus 1. So basically this function fx is defined as minus x when x lies between minus 1 and 1, and it is x minus 2 when x lies between 1 and 3. Now we look at our function gx. Now gx is defined as 2 minus mod of x plus 1 when the value of x lies between minus 2 and plus 2. X plus 1 has a critical point at minus 1. This is plus and this is minus. So now we can write this function gx as, now first we have this interval when x lies between minus 2 minus 1. Now it is 2, and then in this interval this is negative, so minus minus plus, so it will be this 2 plus x plus 1, and then we have from minus 1 to 2. Now here it will be positive, so it will be 2 minus x plus 1. Now gx is basically x plus 3 when x lies between minus 2 and minus 1, and it will be 1 minus x when x lies between minus 1 and 2. Now we need to find f of gx and g of fx. Now first we will find f of gx using graphical method. So we are going to use graphical method and we wish to find f of gx. Now basically f of gx is f and then gx. So essentially values of x will go into this function g, and then value of gx will go into this function fx. Now in this graphical method, what we do is, first step is we'll draw the graph of gx. Now gx is x minus 3 when x lies between minus 2 and minus 1. So between minus 2 and minus 1, this is x minus 3. Now we put x as minus 2, this value is 1. And if we put x as minus 1, this value is 2. So this is a straight line. So this function is x plus 3. Now for this next part, it is also a linear function. So at minus 1, this value is 2. And at 2, this value is minus 1. And at 0, this is 1. So this is 2, then 1, then 0, and then minus 1. And here this definition is 1 minus x. Now there is a definition change at minus 1. So we'll highlight this minus 1. So first step is draw the graph of gx. Now this graph is defined between minus 2 and plus 2, and there is a definition change at minus 1. Now the next step is draw horizontal lines at boundaries of definitions of fx. Now boundaries of definitions of fx are at minus 1, 1 and at 3. So what we'll do is we'll draw a horizontal line at minus 1. So we'll draw this horizontal line at -1. We'll draw a horizontal line at 1. And we'll draw a horizontal line at 3. And in addition to it, we'll write definition of fx. Now, when x lies between -1 and +1, definition of fx is -x. So we'll write -x in between these two lines. And when x lies between 1 and 3, this definition is x minus 2. Now, we'll mark all those points where these lines, they're going to intersect the graph of gx. Now, they're intersecting at this point, and at this point, and at this point. So we have already marked this point. Now this is x equals 0, and this point is x equals 2. So now we'll start writing the definition of f of gx. Now first definition is between -2 and -1. So when x lies between -2 and -1. Now in this case, since both the functions fx and gx, they are continuous, we need not bother about this equality sign. We can take it with this definition, or we can also take it with the next definition. Now in this interval, definition of gx is x plus 3, and this definition will go into this x minus 2. So it will be this x plus 3 minus 2. Now this next interval is between -1 and 0. So it will be this -1 x and 0. And in this case, definition is 1 minus x. Now this 1 minus x, it still lies in this interval. So here 1 minus x will again go to this x minus 2. So it will be this 1 minus x minus 2. And then we have this third definition when x lies between 0 and 2. And in this case, definition is 1 minus x. But here graph lies in between these two lines. So here this definition will go to minus x. So it will be this minus and 1 minus x. So basically f of gx will be x plus 1 when x lies between -2 and -1. It will be minus x minus 1 when x lies between -1 and 0, and it will be x minus 1 when x lies between 0 and 2. So this is our graphical method. Now we'll come to algebraic method. Now before algebraic method, we'll write fx and gx again. Now fx is minus x when x lies between -1 and 1, and it is x minus 2 when x lies between 1 and 3, and gx is x plus 3 when x lies between -2 and -1, and it is 1 minus x when x lies between -1 and 2. Now again we'll find f of gx. So we'll write f of gx. Now in this definition we'll replace x with gx. So it will be this minus gx when gx lies between -1 and 1, and it will be gx minus 2 when gx lies between 1 and 3. So for this f of gx, we have defined everything in terms of gx. Now this gx itself has two definitions, x plus 3 and 1 minus x. So what we'll do is, now we'll expand it in 4 parts using definition of gx. Now first we'll use this definition, x plus 3. So it'll be this minus, and then gx is x plus 3, and then we'll write minus 1 when gx is x plus 3 less than 1. Now here we have to use AND, because this condition, it must be satisfied for these values of x. So Together with this condition, we have to take into consideration domain of x also. So it will be this minus 2 x and then minus 1. Now we'll put this x plus 3 in this second definition. So it will be this x plus 3 minus 2 and then 1, and then it will be this x plus 3 less than equal to 3, and again where x lies between minus 2 minus 1. Our next definition is 1 minus x. Now we'll put 1 minus x in this first one. So it will be minus 1 minus x and then minus 1. 1 minus x is less than 1. And here the condition is the value of x must lie between minus 1 and 2. And then this definition will go into the second part. So it will be this 1 minus x minus 2 when 1 is less than 1 minus x is less than equal to 3 and minus 1 is less than x is less than equal to 2. Now in this, what we'll do is we'll first solve these intervals. Now this is a minus 4 is less than equal to x, and this is less than minus 2, and here it is x lies between minus 2 and minus 1. Now there is nothing common in between these two conditions, so here there is no intersection of values of x possible. So this definition, it is not possible. Now if we look at this, now if we take this 3, then it will be this minus 2 and then x will be this 0, and here it is minus 2 x and minus 1. So in this case we have this common interval between minus 2 and minus 1. So now we write this f of gx, and the first interval where it is defined as between minus 2 and minus 1, and here this definition is simply x plus 1. Now we'll solve this. Now if we subtract 1, it will be this minus 2 less than equal to minus x less than 0, and if we take this minus sign, then it is between 0 to 2, and here it is between minus 1 to 2. So the common interval between these two is value of x lies between 0 to 2. Now here this definition is x minus 1, and finally here it is 0 and then minus x and then 2. So between minus 2 and 0, and here it is from minus 1 to 2. So if we take intersection of these two intervals, it will be between minus 1 and 0, and here this definition is minus x minus 1. So that is the definition of f of gx using algebraic method. Now once we have this definition of f of gx, we can draw its graph. Now when x is minus 2, this value is minus 1. When x is minus 1, this value is 0. So this is x plus 1. Now when x is minus 1, this is 0. And when x is 0, this is minus 1. So this is minus x minus 1. And here, if we take x as 0, it is minus 1. And at 2, this value is 1. So that is the graph of f of gx. Now clearly, this function is continuous in minus 2 to 2, and it is not differentiable at these 2 points where we have these corners. So not differentiable at x equals minus 1 and x equals 0. So this is how we can write composite functions from the two given functions fx and gx. Now we'll draw the graph of g of fx, and here I'm just going to use graphical method. Now for g of fx, it is g of fx. That means value of x will go into f and value of fx will go into g. So here we'll have to draw the graph of fx. So first we'll draw the graph of fx. Now this fx is minus x between minus 1 and plus 1. So at minus 1 it is 1, and at plus 1 this is minus 1. So that's the definition of fx between minus 1 and plus 1. So this is your minus x, and then at 1 this value is minus 1, at 2 it is 0, and at 3 this is 1. So that's the definition, x minus 2. Now there is a definition change at 1. So definition changes at 1, and then boundary values are minus 1 and 3. Now we'll draw horizontal lines at boundary conditions of gx. So we'll draw a horizontal line at minus 2. So it will be this minus 2. And then at minus 1. And then we'll draw a line at 2. Now when x lies between minus 2 and minus 1, definition is x plus 3. So here we'll have x plus 3. And here when x lies between minus 1 and 2, it is the one minus x. Now it intersects only at one point, and this point is already marked. So here we just have two definitions. So if we write g of fx, now this first interval is from minus 1 to 1. So when x lies between minus 1 and 1, definition is minus x, and it will go into this 1 minus x. So it will be this 1 plus x. And then next interval is from 1 to 3. So when x lies between 1 and 3, here the definition is x minus 2, and will still go to 1 minus x. So it will be 1 minus x minus 2. So this function will be 1 plus x when x lies between minus 1 and 1, and it will be 3 minus x when x lies between 1 and 3. Now we'll draw the graph of g of fx. Now for g of fx, when x is minus 1, this is 0. And when x is 1, this is 2. So it is this line 1 plus x. And when x is 1, it is 2. And when x is 3, it is 0. So that's the definition. 3 minus x. Now this g of fx, it is continuous in minus 1 to 3, and it is not differentiable at x equals 1. So this function, it is not differentiable at this point, x equals 1. So we can solve these composite functions either using graph or using this algebraic method. Now we'll take up the second example. Now we'll take this third case where we're given this fx and gx, and we need to find g of fx. Now first we'll use graphical method. We'll draw the graph of fx. Now when x is 0, this is 1. And when x is minus 1, this is 0. So that is the definition of fx. And since 0 is not included, it will be this open interval. And then when x is greater than or equal to 0, this is x square. So it is x square when x is greater than or equal to 0. So in this case, this fx, it has this discontinuity at 0. Here there is a definition change at 0. Now we'll draw horizontal lines at minus 1 and 1. So we'll draw horizontal lines at minus 1 and also at plus 1. Plus 1. Now we'll find their point of intersection. So we have this just one point of intersection here. We have another point of intersection which is given by this value. Now this point is graph of x plus 1 intersecting this line minus 1. So x plus 1 equals minus 1. So this point is minus 2. So basically this point is x plus 1 equals minus 1. And we also have another point of intersection, and this point is this graph of x square intersected by y equals 1. So if x square equals 1, this point is also 1. So here we have three critical points, minus 2, 0 and 1. Now when x lies between minus 1 and plus 1, definition of gx is 2x, and when x is greater than or equal to 1, this definition is 3 minus x. Now we'll start writing g of fx. Now this first interval is x lies between minus 2 and not included 0. Here this definition is x plus 1, and we'll go to this definition which is 2x. So it will be this simply 2x plus 1. Now here, since this function is discontinuous at 0, we do not know whether we have to include 0 here or we have to include 0 in the next one. So what we'll do is, as of now, we won't bother about this equality sign. Now we'll find definition between 0 and 1. So when x lies between 0 and 1, here this definition is x square, and still between these two lines. So we'll go to this definition 2x. So it'll be this 2x square, and finally it'll be this x greater than 1. In this we have x square, and now I'll go to this 3 minus x. So it'll be this 3 minus x square. So that is the definition of g of fx. Now we have a problem with equality signs. So what we'll do is we'll find g of f0. Now f0 is when x is 0, f0 is 0. So it'll be this g0, and g0 is 2 into 0, 0. So we have to include this equality sign at a point where definition of g of fx is 0. So if we put 0 here, it will be 2. And if we put 0 here, it will be this 2x square. So we have to include this 0 here. And in the same way, we will find g of f1. Now f1, it will be 1. So it will be this g1, and g1 is this 3 minus x, which is 2. Now if we put 1 here, it is 2. If we put 1 here, it is 2. Now since it is continuous at 1, we can put this equality sign anywhere. So that is the definition of g of fx. Now we'll solve this using algebraic method. So here we have to find g of fx, which is 2fx when fx lies between minus 1 and plus 1, and it will be 3 minus fx when fx is greater than or equal to 1. Now fx has two definitions. So first we'll consider this definition. So now we write this as 2 and then x plus 1 when x plus 1 lies between minus 1 and 1, and the condition with that definition is x is less than 0. And here will be this 3 minus x plus 1 when x plus 1 is greater than or equal to 1, and here the condition is x is less than 0. Now next definition is x square, so it will be this 2x square when x square lies between minus 1 and 1, and x is greater than or equal to 0, and then it will be this 3 minus x square when x square is greater than or equal to 1 and x is greater than or equal to 0. Now we'll solve these conditions. Now this is minus 2 less than or equal to x less than 0, and this is x is less than 0. So intersection of these two conditions is this interval. So g of fx will be (2x plus 1) when x lies between minus 2 and 0. Now if you look at the second condition, here the condition is x is greater than or equal to 0, and here x is less than 0. Now there is nothing common between the two intervals, so this is not possible. Now if you look at this third one, x square is always greater than minus 1, and x square less than 1 is x lies between -1 and +1. And here x is greater than equal to 0. So intersection is x is greater than equal to 0 but less than 1. In this case, this definition is 2x square. And this third one is x square is greater than 1. That means x is greater than equal to 1 and x is greater than equal to 0. That means x is greater than or equal to 1. Then this definition is 3 minus x square. So this is the definition of g of fx using algebraic method. So this is how we find composite functions from two piecewise defined functions. Now here we're given this function fx, which is greatest integer function of x when x lies between -2 and 0, and this is mod x when x lies between 0 and 2. Now we draw the graph of fx. Between -2 and -1, it'll be -2. And between -1 and 0, it'll be this -1. And when x is greater than 0, mod x is simply x. So it'll be this x. So there's the graph of fx. Now we given this hx, which is secant x in the interval -3 pi by 2 and 3 pi by 2, except all the points where it is not defined. Now if we look at graph of secant x, now this is pi by 2 minus pi by 2, this is 3 pi by 2 and this is minus 3 pi by 2. So this is 3 pi by 2 minus 3 pi by 2 minus pi by 2 and pi by 2. Now this is 1. So we have -1 and +1. And that's actually gx, not hx. Now first we'll find f of gx. So once we have gx, we look at definition of fx. Now critical points are -2, 0 and 2. So we'll draw a line at -2, 0 and +2. And we'll find these point of intersections. Now if we take secant x as 2, then cos x is 1 by 2. And if cos x is 1 by 2, this point is pi by 3. This point from minus pi by 3 to plus pi by 3, and secant x equals -2, cos x equals -1 by 2. So it will be this 2 pi by 3, and this is pi plus pi by 3 is 4 pi by 3. And here we will have -2 pi by 3 and -4 pi by 3. When x lies between -2 and -1, this definition is -2. In between these two, this definition is -1, and here this definition is x. So we can write f of gx as -2 when it lies in this interval, and x lies from -4 pi by 3 to -2 pi by 3, except at this point, which is minus pi, and from 2 pi by 3 to 4 pi by 3 except pi. So there's this definition is -2, and at x equals minus pi and plus pi, this value is -1, because these are the points where this value is -1. And then when x lies between minus pi by 3 to plus pi by 3, both included, this is x. So it will be this secant x. If we draw the graph of f of gx, it will be, now this is -4 pi by 3, and this is -2 pi by 3, and this is minus pi, this is minus pi by 3, this is plus pi by 3, this is 2 pi by 3, pi and 4 pi by 3. Now in between minus 2 pi by 3 and 4 pi by 3, this value is minus 2 except at minus pi where this is minus 1, and here also it is minus 2 except at pi, and in between minus pi by 3 and plus pi by 3, this is secant x. So it will be this value. Now the first question is, limit of f of g exists at which of the following point? Now at minus 1 will lie here. So at minus 1 it will exist. So this a, it matches with p. At pi, so here it is discontinuous, but still limit is going to exist. So this q. Now at 5 pi by 6, which is pi minus pi by 6, it is continuous at this point, so it will be this r. And then at minus pi also will be this s, and at pi by 3. At pi by 3 we have a defined left hand limit but a non-defined right hand limit, and if limit is defined only on one side, then too this limit is defined. So it will be p, q, r, s and t. And points of discontinuity of f of gx will be discontinuous at minus pi and plus pi. So it will be discontinuous at minus pi and plus pi. So this c, it matches with q and s. Now points of differentiability of f of gx. Now at minus 1 it will be differentiable. So for d we have p. At pi it is not differentiable. At 5 pi by 6 it will be differentiable. So it will be this pr. At minus pi it is not differentiable. At pi by 3 we just have to check its left hand derivative, and left hand derivative for this function will exist. So it will be this p, r and t. And then we have this g of fx. Now for g of fx, definition is only secant x, but here x should not be plus pi by 2. So this is one value missing, and this value will be at pi by 2. So g of fx will be secant minus 2 when x lies between minus 2 and minus 1. It will be the secant minus 1 when x lies between minus 1 and 0, and it will be secant x when x lies between 0 to 2 except pi by 2. Now this limit, it does not exist at minus 1, and all the points it is defined. So this b, it matches with p, and that is the answer to this question. Now question number 20 is, let function fx is e to the power gx and gx is sine mod of x square. Now we know that mod x is either minus x or plus x, but there is an even power. So even if we'll take minus, it'll again be plus. So we can write this gx as sine square x, and then this function fx will be e to the power sine square x. Now exponential functions sine square and x square, they are all continuous and differentiable. Now this function g, it is differentiable at all x, and that's your option number D. Now question number 28 is, we are given two functions fx, which is 1 when mod x is less than equal to 1, and 0 when mod x is greater than equal to 1, and gx, which is 1 when mod x is less than equal to 2, and 2 when mod x is greater than equal to 2. We have defined two functions h1 and h2, which are compositions of f and g. Now we'll take h1x. h1x is f of gx. So we'll take this function fx. We can write f of gx as 1 when mod of gx is less than equal to 1, and it is 0 when mod of gx is greater than 1. Now looking at the value of gx, so gx is 1 when mod x is less than equal to 2. So that means we can write h1x as 1 when g1x is equal to 1, that is when mod of x is less than equal to 2, and it will be 0 when gx is 2, that is when gx is greater than 1. So it will be when x is greater than 2. So this function, it is discontinuous at x equals plus or
minus 2. So h1x, it is discontinuous at plus or minus 2. Now what about h2x? Now h2x is g of fx. Now g of fx will be 1 when mod fx is less than equal to 2, and will be 2 when mod fx is greater than 2. Now fx can take the value 1 and 0. So that means it cannot take the value greater than 2. So the only option that we have here is g of fx will be 1. So this h2x, it is nothing but a constant function. So this function will be continuous for all x belongs to R. So answer to this question is h1 is discontinuous at plus minus 2 and h2 is continuous. So h2 is continuous everywhere and h1 has discontinuity as plus minus 2, and that's your option number C.
Now here we are given 4 functions f1, f2, f3 and f4, and we have to find this matching. Now first one is f4x. Now we are given that f4x is f2 f1x if x is less than 0, and it is f2 f1x minus 1 if x is greater than or equal to 0. Now what we'll do is we'll draw the graph of f1x. When x is less than 0, it is mod x. That means it'll be this minus x, and when x is greater than 0, it is e to the power x. Not included here and included here. Now if you look at f1x, f1x is always greater than 0. So this function, when x is less than 0, definition is minus x and it'll go to x square. So it'll be this x square, and when x is greater than or equal to 0, this definition is e to the power x, and again it'll go to x square. So it'll be this e to the power 2x, and then we have this minus 1. Now if we draw the graph of f4x, when x is less than 0, this is x square, and then we have e to the power 2x minus 1, which is this graph. So if we look at this p, it is onto but not 1 1. Codomain of f2 is from 0 to infinite, and range of this function is from 0 to infinite. So this first one is correct. So p, it matches with 1. It is neither continuous nor 1 1, not true. Differentiable but not 1 1. So if we look at differentiability, then here derivative is 2x and here derivative is 2 into e to the power x. Left hand derivative 0, right hand derivative 2. So it is not differentiable. And d is continuous and 1 1. So p is only mapped with 1. Now we look at f3. f3 is this function, sin x and x. Now if we draw the graph of f3, when x is less than 0, this is sin x. And when x is greater than 0, it is this x. Now range of f3 is 2, so it is not onto. So this option A is incorrect. It is neither continuous nor 1 1, wrong. Now we have to check its differentiability. Left hand derivative is cos x and cos 0 is 1. Right hand derivative is 1, so it is differentiable. So it will be this differentiable but not 1 1. So this q, it matches with 3. Now f2 OF1, basically it is this graph except for this minus 1. So if we draw this graph, it will be x square when x is less than 0, not included, and then here will be this e to the power 2x. So that is the graph of f of fx. This is not onto. It is neither continuous nor 1 1. So that means this 2 is true. So for this r, it will be this 2, differentiable but not 1 1, not true, continuous and 1 1, not true. And finally we have this f2. Now this f2 is x square when x lies between 0 to infinite. So it is this function. Now this is continuous and 1 1, and that's your option 4. So this S, it matches with 4. So it is 1 3 2, 4, and that's your option D. Now it says G is a differentiable function with G0 equals 0, G dash 0 as 0, and G dash 1 unequal to 0. Now we have defined this fx as x upon mod x gx when x is unequal to 0. So we'll split this definition in 3 parts. When x is less than 0, x upon mod x is minus 1, so it will be simply minus gx. It is 0 for x equals 0, and it will be this gx when x is greater than 0. So that's your function fx, and we are given hx as e to the power mod x. Now which of the following is or are true? Now if we look at this fx, then f0 negative is minus g0 negative, which is 0, and f0 positive, it is g0 positive, and that is 0 since gx is continuous at x equal to 0 and f0 is equal to 0. That means fx is a continuous function. If we find f dash x will be minus g dash x when x is less than 0, and will be g dash x when x is greater than 0. Now if we look at f dash 0 negative, it will be minus g dash 0, which is 0, and f dash 0 positive, it will be g dash 0, which again is 0. That means this function is differentiable at x equals 0. So this option A, it is correct. Now h is differentiable at x equals 0. Now if we look at this hx is basically e to the power minus x when x is less than 0, and e to the power x when x is greater than or equal to 0. Now we differentiate this. H dash x will be minus e to the power minus x when x is less than 0, and will be e to the power x when x is greater than 0. Now h dash 0 negative, it will be minus e to the power 0, which is minus 1, and h dash 0 positive, it will be this e to the power 0 plus 1. So hx is not differentiable at x equal to 0. Now we look at h of fx will be simply e to the power mod of fx, and will be this e to the power mod of x upon mod x into gx. Now since we have this mod sign, so mod x upon mod x will cancel, so it will be equal to e to the power mod of gx when x is unequal to 0, and it will be equal to e to the power 0 1 when x is equal to 0. So that is the definition of h of fx. Now we have to find its differentiability at x equals to 0. Now we differentiate this, we can write d by dx of h of fx will be e to the power then mod of gx into mod of gx upon gx into g dash x. Now at x equal to 0, this g dash 0, it will be 0, and this value will be either plus 1 or minus 1. That means both left hand derivative and right hand derivative, they'll exist. So h of fx will be differentiable at x equals to 0. That means this option D is correct. Now what about f of hx? Now f of hx will be e to the power mod x upon mod of e to the power mod x into g into e to the power mod x when e to the power mod x, it is unequal to 0, and this is true for all x belongs to R. So that is the only definition that we have. So here this will cancel. So f of hx is g into e to the power mod x, which we can write as g into e to the power minus x when x is less than 0, and is g e to the power plus x when x is greater than or equal to 0. Now we differentiate this, it will be this g dash e to the power minus x into minus 1, and here will be g dash e to the power x into e to the power x. Now if we look at its left hand derivative, if we put x as 0, we'll get this as g dash 1 and then minus, and its right hand derivative will be simply g dash 1. And the question it is given that g dash 1 is unequal to 0, therefore this left hand derivative is not equal to right hand derivative. That means this f of hx is not differentiable at x equal to 0. So the only correct options are A and B. Now here the question is, we are given this function fx which is 15 minus mod of x minus 10. Then we need to find set of all values of x for which gx, which is f of fx, it is not differentiable. Now gx will be 15 minus mod of fx minus 10. So it will be this 15 minus, and fx is 15 minus x minus 10 minus 10. So it will be this 15 minus 5 minus mod of x minus 10. Now mod x function, it is not differentiable at x equals to 10, and it will also not differentiable at 5 minus mod of x minus 10 equals 0, that is x minus 10 equals plus or minus 5. So at x equal to 5 and at x equal to 15. So not differentiable at 5, 10 and 15, and that's your option B. Now here the question is, we are given two functions fx and gx where a and b are non-negative real numbers. Determine the composite function g of f, and if g of f is continuous for all real x, determine the values of a and b. Now for g of f, we'll draw the graph of fx. Now here a and b, they are both non-negative real numbers. So this first one is x plus a. Now this is minus a, this is 0, and if x is 0, this value is a. And then we have this mod x minus 1. Now we can start it below this graph or above this graph. It actually doesn't make a difference because definition of gx changes at x equal to 0. So we'll draw this graph. This is 1 and this is 1. This is x minus 1 and this is minus x plus 1. Now definition of gx, it changes at x is less than 0. So in this part, this definition is x plus 1, and here the definition is x minus 1 whole square plus b. And we have this point of intersection. We have this definition change here, and at 1 we'll go with this definition. So we'll start writing g of fx. Now the first one is when x is less than minus a, definition is x minus a, and it goes in this x plus 1. So it will be this x plus a plus 1. Now second one is when x lies between minus a and 0. Now here again this is x plus a and go in x minus 1. So it will be this x plus a minus 1 whole square plus b, and then we have from 0 to 1. So if x lies between 0 and 1, this is minus x plus 1. It will go in this. So it will be this x square plus b, and x is greater than 1, then it will be x minus 2 whole square plus b. So that is the definition of g of fx. Now it says this function is continuous. Now at minus a, left hand limit is minus a plus 1. So it will be this plus 1. And here if we put x as minus a, it will be this 1 plus b. That means value of b is 0. Now if we look at 0, at 0 negative, it will be this a minus 1 square and plus b is 0. And here it will be this 0 and plus b is also 0. So value of a must be 1. So from this we can get the value of a as 1 and value of b as 0. So if we have the value of a and b, we can write g of fx. Now this g of fx will be x plus 2 when x is less than minus 1. It will be x square when x lies between minus 1 and 0. It will be x square again when x lies between 0 and 1. So we'll take it from minus 1 to 1, and here it will be x minus 2 whole square when x is greater than or equal to 1. Now we already know this g of fx, it is continuous. We have to find whether this function is differentiable or not differentiable. Now if we find its derivative, it will be this one when x is less than minus 1. It will be this 2x between minus 1 and 1, and it will be this 2x minus 2 when x is greater than 1. Now f dash minus 1 negative is 1, and f dash minus 1 positive, it will be minus 2. F dash 1 negative is 2, and f dash 1 positive is minus 2. So it is not differentiable at x equals minus 1 and 1. And they have asked for its differentiability at x equal to 0. And since we have this x square definition, when x is 0, this function is differentiable at x equals 0. Now the question is, we are given this function fx, which is mod of log 2 minus sin x, and this gx is f of fx. Then we have to check for differentiability of g at 0 and g dash 0. Now when x tends to 0, sin x is nearly 0. In that case, log 2 minus sin x, it will be greater than 0. That means this fx will be simply log 2 minus sin x. So this gx, it will be f of fx, which is log 2 minus sin fx. Now we differentiate this, we can write g dash x as minus, now this is cos fx into f dash x, and f dash x is minus cos x. So we can write g dash x as cos x into cos fx. Now if we put x as 0, we'll get g dash 0 equal, now cos 0 is 1, and this is cos f0, and f0 is simply log 2. So g dash 0 is cos log 2, and that's your option B. Now here the question is, we are given this function fx, which is x cube plus 3x plus 2, and g of fx, it is x, and h of g of gx, it is also x. Now if we replace this x with fx, we can write h g, and g of fx, it is equal to fx. Now g of fx is x, so from here we can say this h of gx is actually fx. Now we have to find h of g3, then h of g3 will be simply f3, and f3 is 27, 27 plus 2, 29, 29 plus 9, 38. So this is 38. That means this option D is incorrect. Now again, if we replace this x with fx, we can write h of g of fx, it is equal to f of fx. Now g of fx is again x, so we can write hx as f of fx. Now if we find h0, h0 will be f of f0. Now f0 is 2, so this is f2, and f2 is 8 plus 2, 10, 10 plus 6, 16. So this value is 16. That means this option C is correct. Now we have to find h dash 1. We have to differentiate this. We can write h dash x as f dash fx into f dash x. Now f dash x is 3x square plus 3. Now we need to find h dash 1, and h dash 1 is f dash f1 into f dash 1. Now we look at f1. f1 is 6. So it will be this f dash 6 into f dash 1. Now f dash 1 is 6 and f dash 6 is 111. So this value will be 111 into 6, and is going to be 666, and that means this option B is correct. Now we have to find g dash 2. So we'll differentiate this. We can write g dash fx into f dash x, it is equal to 1. Now we need g2, and we know that f0 is 2. So we'll put x as 0. So it will be this g dash f0 into f dash 0, it is equal to 1. Now this is g dash and f0. f0 is 2 and f dash 0 is 3. It is equal to 1. So value of g dash 2 is 1 by 3. So the only correct options are B and C.